Hello. Hopefully the camera's set up straight enough for you, Trey, and hopefully it doesn't shut off on me like it did yesterday. Today we're talking about comparative graphs found on page 611. Again, I think it'll be a lot easier if you have your book with you because there are quite a few graphs on this one. I'll try to remind you before you go home today to grab that. And if I didn't, I'm going to feel like a silly fool. Again, page 611, we're talking about comparative graphs. The objectives for lesson 93, we're going to make and interpret line and bar graphs. On page 611, the first example that we'll discuss is a bar graph. Okay, and again, I'm not going to draw that picture. I'm not even going to attempt to draw that picture, but it's on page 611. It looks like this. Alright, it says the average daily high temperatures in January and July for the cities are displayed in the comparative vertical bar graph below. And it looks like the light blue is January, the dark blue is July. And of course, typically the July temperatures are warmer unless it's in the southern hemisphere, and then everything flip-flops. Question A, it says, in which city was the average July high temperature highest? So I'm going to look at my dark blue, and I'm going to look at which one looks like the July temperature is the highest. Okay, and it looks like the answer for that one, okay, example 1, you're going to write A, and that would be Rome, Italy. Again, you can clearly see that temperature, it looks like the temperatures on the left-hand side are in Fahrenheit. They go by 10-degree increments based on each horizontal line, and then they list every 20 degrees Fahrenheit. That one looks like it's 89 degrees Fahrenheit, which is a little bit higher than the Tokyo, Japan one. All right, practice problem B, in which city was the average January high temperature lowest? Okay, this is still example 1. B, what was it lowest? Well, again, it asks us for January. I look at the light blue bar. Which one is the smallest? It looks like Paris, France is lower than Tokyo, Japan. Looks like it's at about 42 degrees Fahrenheit. So for question B, I'm writing Paris, France. Okay, part C of example 1. It says, which city has the smallest range between these temperatures? Do you know why? Well, the range, of course, is the biggest one minus the smallest one. And I'm just going to look at those two graphs. Which two look really close together? Well, as I look, it looks like Caracas, Venezuela, both of those fall in the 70s. It looks like the January temperature is about 71. The July temperature is only about 78 or 79. So I'm going to go with that. Being it's only 8 degrees difference, and then sure enough the answer is found on the bottom. It says the smallest difference in heights of the bars occurs in Caracas, Venezuela. Caracas, Venezuela is your answer for part C. Again, because the difference of the January and July temperatures is the smallest. If we compared that to, I guess the second closest one would be Sydney, Australia. It still looks like 79 degrees in January and only 61 degrees in July for a difference of about 18 degrees Fahrenheit. So Caracas, Venezuela is clearly the smallest. Part D, example 1, part D says, for which city is the average January temperature greater than the average July temperature? Do you know why? Alright, and if we look, let's try to find one that has a higher light blue bar or higher bar in January. And it looks like Sydney, Australia is higher. So our answer for part D is Sydney, Australia. And I gave you the answer at the beginning of it, but it says we look for the city that has a light blue bar that is taller than its dark blue bar. We find that Sydney, Australia. Australia is warmer in January than in July because it's south of the equator. And in science, we've kind of talked a little bit about that. The seasons are basically flip-flopped in, I guess, in the southern and northern hemispheres, because in the southern hemisphere, that tilt of the Earth axis kind of makes it closer to the Earth, or closer to the sun, when winter time comes in the northern hemisphere. All right, and that's something that hopefully you understand, and hopefully you know already. All right, example 2. Example 2, it says we can use a double line bar graph to show how two or more things change in relation to one another. For example, the double line graph below shows the change in population of the cities in Austin and Pittsburgh from 1950 to 2000. The legend on the right tells us which line belongs to which city. Again, it's going to be a lot easier if you take your books and you open these up to page 612, because that bar graph, or that line graph, is on the page, and I can't draw it nearly as well as they can. So look at that bar graph on the top of page 612 to answer the questions for example 2. Okay, it says A for example 2. Okay, part A. It says approximately what was Austin's population in 1970? Well, it looks like the years are on the bottom and the populations run on the left hand side. And I'm just going to find the year 1970 and go up to the line that represents Austin's population, which is the solid circles. And in 1970, it looks like it was at about 250,000. Okay? So part A, your answer is 250,000. Okay, part B, it asks us another question. Approximately how much did Pittsburgh's population decrease between 1950 and 2000? Okay, so Pittsburgh's population from 1950 to 2000 decreased. We have to first find the population in 1950, and it looks like it was right at 700,000. Okay, we subtract that from the population in the year 2000, which was 350,000. Okay, to find out the difference between the population in 1950 and the population in 2000. Of course, 0 minus 0. Here we have to borrow. 10 minus 5 is 5. 6 minus 3 is 3. The difference in population between 1950 and 2000 was 350,000. And that'll be your answer for part B of example 2. We are going to draw a graph. I'd like you to flip your sheet around and draw this graph on the back side of your YouTube assignment sheets, or whatever we want to call them. Okay, let's draw a graph. Let's do part B. Okay, it says display this data in a double line graph. Part B, for a science project, Maya and Lonnie each planted a seed. A record of the height of each seeding is shown below. Display the data in a double line graph. Alright, so if we look at our double line graph that we kind of had earlier, we can get a pretty good start. Okay, most of them are surrounded with a rectangle. Alright, and now we have to place our information in here. On the bottom side, okay, down here we have to either put the weeks. We'd probably show the progression of time on the bottom. On the left side, let's put the height of our seeds. Alright? I'm going to move this up just a little bit. Okay, so let's go, I guess, time on the bottom. We've got, maybe let's do time in weeks. Okay, we'll just write 1, 2, 3, and 4. Okay, I kind of like it spread out a little bit more. I like it pretty even. Alright, so let's go here. 1. Okay, now you're drawing your lines vertically from here all the way up to the top. You can use a ruler, you can use a straight edge if you'd like to. On the left side, we have to decide, I guess, we're going height. This side is representing height in centimeters. Okay, it looks like the highest it gets is 20 centimeters. So we don't have to go much over that. I guess let's just do it in fives. Let's split this up into 4 parts. This, of course, represents 0. And this will represent 10, 20, and then we'll go 5 and 50. Okay, and then again, our height is in centimeters, as we can see there. Now we have to draw our horizontal lines, just so everything's lined up really nice. Alright, and we need to have a key. So we've got Maya's seedling and Lonnie's. Let's just, off to the side, I'm going to use different colors. If you look back to page 612, they represented different pieces of information with like open circles. Oops. They represented it with open circles or with closed circles. And then they could see the difference in the 2 lines. But we've got different colors here, so that's what I'm going to do, but you can feel free to use the open or closed circle method as well, like the book did. Oh, hope I didn't go too far. Okay, so let's go. Let's do Lonnie in blue, and let's do Maya in red. Okay, and I'm going to make my marker really thick, and I'm going to do Maya's first. Looks like Maya's seedling at 1 week was 1 centimeter. That's way too big. Okay, so Maya's at 1 week, still way too big, was 1 centimeter. So right down here. At 2 weeks it was 5. At 3 weeks it was 11. And at 4 weeks it jumped up to 20. Okay, and now we have, I'm going to use blue for Lonnie. Looks like at week 1 it was 2 centimeters. Week 2 it was 4. Week 3 it was 10. And week 4 it was 16. Okay, now we can of course connect our dots. Okay, and we can clearly see that, I guess Lonnie's seedling started off growing a little bit faster, but ended up being behind Maya's. Maya's started off a little bit slower, but then kind of took off. Alright, and I guess this is all we need to do for the assignment today. Have a good night, and we'll see you tomorrow.